Hello. Today we have what I would call a quorum. And we have one new person. Your name is what?
Mary, like Merry Christmas, M-E-R.
Don't say your last name, because
No,
you're
Mary.
Mary.
So not Mary, Mary.
Mary, okay. And your relationship to astronomy is basically none.
None.
There you go.
I just love it.
Okay. And Kurt, you're back. So that's cool. And you're back. Cy. Thank you. So that's pretty good. We have and you're back.
And I'm married too.
Mary.
Yeah.
Yes, right. And just giving away the fact that I never can remember people's names, even if you've been here for
Join the rest of us.
right. How long have you been here?
Starting way back at the beginning,
So
I have no idea.
No, it's maybe 8 years.
8
8 years, right?
10
I can't get your name right. It's nothing personal, right? Sit in the first row, talk to you every week. I don't know your name.
That's all right.
Anyway, so my lack of memory doesn't. Well, all that means is that when I prepare lectures, it's fun for me because I don't remember what I learned last week. So it's all fresh and new to me as well. You know. So when there's something new in the universe going on, I'm happy to report about it because like next week it'll be old news. Also, it'll be old memory. I won't remember it. So this is a good week for astronomy because there's stuff going on. And in fact, it's the stuff that's going on is more hype, the usual hype. Is there anything really going on in the universe that would demand our attention at any point? And the answer generally is no, except this week the answer could be generally, oh yes, it really could be. There is a nearby star, and by nearby, I do mean less than 1,000 light years. Nearby in the sense that you would recognize that star when you look up in the sky in the winter. That star, if there's one constellation in the sky that you would recognize, and I do not think it's the Big Dipper so much as Orion, right? Orion, you driving down the road and you see Orion, it's right hanging there in front of you rather than the Big Dipper, which is up there. And you're looking at Orion, and one of the stars in the Orion constellation is, kind of right here, or as you're looking at it right here, and the armpit of Orion. And in the armpit of Orion, there is a star. That star is known by various names, all of it spelled the same. But you might call it Betelgeuse because you saw the movie, and I would call it Betelgeuse. But same star. What's true about it is that it's bright. It's sometimes the sixth brightest star in the sky, and it's yellowish, and it's in the best constellation. So it's really, if you will, one of the most famous stars. Would somebody go back there and tell them to be quiet? Thanks. So it's best star in the sky, if you will, best named star, most famous star, and one of the things that most people don't know about that star is that it varies in brightness. It's a variable star. It sometimes is brighter, sometimes it's dimmer, but it's always in the top 10 stars in the sky, the brightest stars in the sky. So, for you and I purposes, we don't need to see the difference. If you happen to be a shepherd, then you would be a person who knew that the star got brighter and dimmer over time because that's what you do for entertainment. Look at stars. Well, people who do look at stars for entertainment, who are often called amateur astronomers, are often the first people to notice something in the sky. And what they have noticed recently is that Betelgeuse has been dimming. And dimming is okay because it's a variable star, but it's dimming so much that people are getting concerned, you see. And not in a bad way, but in a good way. I mean, concerned like if something's going to happen, that'll make us really happy because it's 700 actually light years away, more or less. So if anything happens to Betelgeuse, it surely could not affect us that much, and that is true. Nevertheless, we want to know what could possibly happen to Betelgeuse. Well, Betelgeuse is known as a hypergiant star. It is one of the biggest stars in the sky. And And as a big star in the sky, it has the unfortunate, for it, fortunate perhaps for us, unfortunate property of not living very long. Big stars are profligate in the way they consume their nuclear fuel. And I mean profligate. See, we, our star, thank you for all the light in the room and all the light outside, and it has been doing that for 5 billion years, and it will continue to do that more or less unabated and unchanged for another 5 billion years. That's not quite true. In a few billion years, things are going to get pretty nasty on Earth because of the sun, but basically the sun is going to keep doing its thing for 10 billion years. That's 10 to the 10th, no, that's, yeah, 10 to the 10th years. 10 to the 10th years. On the other hand, if you burn your fuel at a rate that is 1,000 times faster, 10 to the 3, you subtract 3 from 10, and you don't get, so 3 from 10 makes 7, okay? So that's 10 to the 7th, that's 10 million years. Betelgeuse is using up its fuel in 10 million years. That's a significant number. Dinosaurs, 60 million years ago. Betelgeuse came on the scene, was born 10 million years ago. 10 million years ago, there were, the common ancestor of apes and humans were more or less, working on who'd be the eventual descendant who became us. But certainly the monkeys were there, and so was Betelgeuse being born 700 light years from here. Betelgeuse will die, according to many estimates, any day now. Any day now. Now, the thing about any day now, as far as a astronomer is concerned, means essentially to an astronomer any one of the next 100,000 years. That's any day now. No, really. For example, the sun was born 4.5 billion years ago. But when it was born, it also was born at the same time the planets were born. They were actually born on the same day. The planets and the sun were born on the same day. But it's an astronomical day. That means that any time in the first 10 million years after the sun was born, the planets were born. But that's the same day as far as we're concerned. So it's really, it's just, I lost my train of thought, but because I didn't want to go to planets, I wanted to go back to Betelgeuse, which is now in its 10th million year, more or less. We don't know this thing because Betelgeuse did not come with a birth certificate, so we actually don't know how big it is. We actually know how big it is, but we do not know how old it is, and we certainly don't know when it's going to die. But we think that meaning mostly the press, as far as I'm concerned, and some scientists, think that within the next 100,000 years. But the fact that it's dimming more than it's ever dimmed since humans have been watching it with instruments, we think it might be significant. It maybe is doing something that is preparing itself for an explosion. And if it is, that can be a lot of fun. And not dangerous at all for us. What can happen? The star will explode. The star will do its thing within seconds. The sky will light up within minutes. And the sky will have a new star that will be as bright as the full moon for a period of perhaps a month or two and be visible to the naked eye for years to come. A new star. A nova, but not just, that's new star, but not just any nova, a supernova, and that supernova could go off in our neighborhood any day now,
next 10,000.
in the next 100,000 years. Right, but nevertheless, it's still trustworthy, right? Because it sells newspapers, and I'm impressed because the very idea that you have a star that has changed so much that if you look at it in the sky, you would look at it, and you've seen the Orion constellation, and you've seen the armpit of Orion, and you know what that star looks like, and to your eye, it might look different. That's significant. Even to a city dweller who occasionally goes out into the country, you would see that. It's different. I'm saying this knowing full well that I haven't seen this, and that I do have a country house, and I will be going up there this weekend. And I fully intend to look up in the sky, because I know exactly where Orion is. He's right down the road, right over there, about this high in the sky, and I'm going to look to see if I can tell the difference. But maybe you can if you're paying attention.
Ethan Siegel has a story.
Say again?
Ethan Siegel has it.
On his thing.
Yeah.
I've stolen a lot of stuff. There's a lot of stuff, I always steal my lectures, that's not true. What I do is I read everybody else's stuff, and then I repeat stuff. So Neil deGrasse Tyson, for example, who writes very well, and he is one of my new heroes. Carl Sagan was my original hero. You all know that. So he writes that the star is so large that if you put it where the sun is, replaced the sun with Betelgeuse, not only would Mercury be inside this new star Betelgeuse, but Venus would be inside of it. The Earth would be inside of this star. Mars would be inside of this star. Even asteroids, and maybe even Jupiter, would be inside this star. That's insane. Let me show you a picture of that graphic. So I'll turn my camera to see if it points to something interesting. Oops. And so this is Betelgeuse. This is Betelgeuse, and you see the picture of the star. It doesn't look terribly round. It looks like it's bumpy and it's got certain diseases, and it does, because there's stuff going on this star that makes it not round. There's all sorts of minor explosions, gas. It's a big. It's got weather. It's what it is. It's got weather, and the weather pumps up parts of it that way and pumps stuff of it that way. And look, so there's Betelgeuse. By the way, this is not a picture, because while we've taken pictures of it, you can't take a picture of a disk, no matter how big it is, that's 700 light years away. Light years. You take a picture of a star with a telescope, you know what you get? A dot. That's it. You make a bigger telescope, you still get a dot. You don't get the disk. But Betelgeuse is so big that they actually have pictures of the disk, and when they do, they don't look anything like this. This is an artist's conception. Okay. But this is the sun right there, for comparison, in terms, not size-wise, but just in terms of where it is. And then this is Mercury, Venus, Earth, Mars right here. Okay, there's Jupiter right here. Okay, Jupiter right here, and you can see the gases that are coming off of this star emanate as far as Neptune down here. Right, so Betelgeuse is basically busy filling its space with all sorts of stuff going on. I got to thinking about this, and I thought, well, wait a second. Betelgeuse is 10 times, more or less, more massive than the sun. 10 times more massive than the sun. But it's 1,000 times bigger. That doesn't make sense. How can, it should be 10 times bigger, but it's not. It's 1,000 times bigger. So I wrote an equation on the board, and I know how much you guys love math. There's never any math in this class because even though it qualifies as 7th grade algebra, it's still beyond most of you. That's not to say that, I mean, everyone in this class has at least a bachelor's or a master's, and sometimes even beyond that. So it's not like this is insolvable. Nevertheless, when I did teach astronomy to students who really shouldn't have been in college because they were passed all the way up into college, and I gave him this equation on the board like this, and I told him, actually I gave him this equation, which is density. That's the word for density. Rho is the word for density. It equals mass over volume. Okay, and I said, if I tell you the mass and the volume of the Earth, can you please tell me what the density was? That was on a question on the test that I gave them, and I gave them the equation, and only half the people got it right. Okay, so although I know that you people are way beyond 7th grade capability, I'm going to go the entire distance with this equation here. Look at it. Volume equals 4/3 pi r cubed. That is the volume of a sphere. It's a very nice thing to know. Volume equals 4/3 pi r cubed. Density equals mass over volume. Well, but that tells you basically that if I increase the mass by 10, okay, well, the density could increase by 10. But the radius, according to this, has been increased by, well, let me see, I want to do this right. If I increase the no, I want to do it in such a way that you can understand. The nice thing about this is that although you're staring at me wondering where I'm going to go with this, the people who are watching this on YouTube will not be so mystified because I'm going to cut this out. So I could really screw this up for another minute or two, and I know you'll be with me. But the people who are already on watching me on YouTube will be anyway. So anyway, what I was trying to do is this, and I don't think I'm going to get there with this. If you increase, let's say you take the mass and you increase it by 2 times 2 times 2, that's 2 cubed times, okay? You should 2 times 2 times 2 cubed. So you put 2 in there, see, and it's cubed. So you get if you put 2 there, I mean instead of 1, you put 2 there. Then this number becomes 8. So the volume should have become 8 times bigger, but it didn't become 8 times bigger. When you increase it's incredibly bigger. Something has changed. I'm not doing this as well as I want. The point that I'm trying to make, not well, is the density of this star has got to be really, really low, because it's only 10 times bigger in mass-wise, but it's subsumed most of the inner solar system. So this gas giant is, while gigantic, is mostly fluff. Now, it's still doing some amazing things, because even though it's mostly fluff, it is also incredibly dense in the center, where it's busy making the energy that's keeping the fluff up. See, the fluff is being held up by the energy of the star being made in the center. So as long as the energy in the star is as long as energy is being made, the star can stay up and even puff up as it has, because inside there's something taking care of the fluffiness. It's fluffing the star. But the problem is the star is ceasing. It's using up its fuel. It's using up its fuel. I can show you the kind of fuel that it's using.
These are these atomic reactions?
These are fusion reactions. You should know your husband is an expert on this.
Not really.
He has a PhD in this. Yes, he does.
No. I had a good chemistry.
Yeah, but your husband is actually
it's his field.
he is his field. Nuclear physics, I believe.
That's
Yeah.
correct.
So the thing is, to find out what's going on inside the center of a star, well, you just have to look at us. There's the human body over there. I'll point that camera at that. Here's the human body. And the human body is made up of 10% hydrogen. Well, the universe is made up of I forget, 75 to 90% hydrogen. And then the rest of the universe is made up of helium. And there's nothing left. There's a couple of trace elements. And those are oxygen, carbon, nitrogen. Those things are also found in the universe, but they're generally found inside of stars. The universe is mostly hydrogen and helium. Those things are found inside of the center of stars. They are being made by the stars. And the thing is, in order for them to have gotten into my body, that star has to explode. So that's exactly what we have. I have a supernova to thank. By the way, would you like my new outfit? Yes. It's a present. It's a present from my son-in-law, who decided that I need a lot of help with my outfits. So he bought me a pair of pants that were one size smaller waist, one size shorter, and he got me this thing. So
They're very, very chic.
Very
yes,
nice.
never in my life have I looked this good.
You look like an astrophysicist.
Right, thank you. But thanks to not just my son-in-law, but also thanks to exploding stars, I also look this way. Because without the hydrogen, without the oxygen, the carbon, and the nitrogen, and a number of other trace elements, even other is mentioned up here at the top of the head. So there are number of other trace elements that are found. All of those were made inside of stars. So that's what Betelgeuse is busy doing. It's making those things for our benefit, or for the benefit of generations of future beings to come. And I am personally if I had to vote, I am personally of the belief that life is everywhere in the universe, not intelligent life like us, but life is everywhere. And if life is everywhere, then it needs those building blocks. So Betelgeuse is going to explode and provide the building blocks for coming generations of life forms yet to be invented.
Was it Sagan that said we are star stuff? Was that
It was
his-
Sagan who said we are star
Yeah,
stuff.
was his quote. Okay.
Yeah, the stuff of the beings are made.
Yeah.
Right.
Oh, yeah, who was that? Who was that?
Zelda Fitzgerald.
Oh, that Fitzgerald. Wow.
Yeah. So let me see if I can make that clear. So this is, imagine you're looking out into the sky, and you see all the stars in the sky. You can represent a sphere as this kind of mapping. You've seen this. You can take the Earth and map it onto that kind of mapping. This is the whole sky, 360 degrees around. The whole sky, everything, all the stars in the sky are in this picture, because this picture is taken by a satellite that took pictures of billions of stars. So this is a billion stars in this picture. Well, this is a sample of a billion stars. And I'm gonna let the video run a little bit, and I'll explain what it's doing. So the video, try to imagine that we've asked a small little child to take this flat picture and to move the red stars that way and the blue stars this way. So that small little child is busy moving the little star dots on the flat piece of paper, and she's moving it, the red stars to the right, and the blue stars she's moving to the left. That's what she's doing right now. That's all she's doing with this picture, all the stars that were in that picture. Okay, that's what she did. She's very good at this. So she moved all the stars left and right, okay? And the red ones are hot, cold, dim. Not dim, sorry, are not hot. They are cool. The red ones, the blue ones, I'm sorry, are warm. That's, blue hot, red hot. It actually works for this sort of thing. Now we've asked the child to rearrange the stars according to which ones are the brightest ones. Now for this, she has a problem because she's not just looking at the picture. She needs to look up, for each one of these stars, she has to consult a database. It says, this star is brighter, so I'll put it here. This star is dimmer, so I'll put it here. So she's going to move the bright ones up and the dim ones down. That's what she's been told to do. She's a 7th grader, so she can do this. The first part could have been done by a 3rd grader. But so she's moving the bright ones up and she's moving the dim ones down. That's what she's done with all the stars in the sky. And she has created the Hertzprung-Russell diagram by doing so. And she created the main sequence of stars, and some are blue, but they're here. These are the red giants, and up here are the supergiants. And these stars here, how did they get here? Because they are no longer in their adolescence. They left this part of the diagram tens of millions of years ago and went up there. And that's where Betelgeuse sits. Betelgeuse, you can't sit in the front row, there's no room. Oh, yes, there is. I'm sorry. Yes.
But that's not where they actually are.
No, see, the thing that you would confuse is that this is spatial, and this is not spatial. This is XY axis, where X is height and Y is age, or it's just data. It's all just data, not spatially. But it looks as if it's real, but it's not. Yes.
So why are the bigger, brighter stars cooler?
Why are the bigger, brighter stars cooler?
Real big giants are all clustered.
Okay, so Betelgeuse was over here, and it was bright, and because it was bright, okay. But then it got brighter and got bigger, and because it got bigger, it's the same amount of energy is being produced. It essentially, the outer layers were inflated, and they're no longer as because the same amount of heat inside has to be distributed over a wider area, so it becomes cooler on the outside.
I'm a bit confused though from way back when I saw this the first time. For instance, Earth can never become a supernova because you're
The
saying,
sun.
Yeah,
the sun.
I meant our sun.
Yeah.
Because you were saying that Betelgeuse was born way down with the cool small blue stars.
It was not a small. It was born as 10 to 20 times the mass of the sun. It was never a gentle giant. It was always a giant star. It was always a massive star.
So
our
Earth
sun
is kind of on the low middling. I mean, our sun. I keep saying Earth.
Our sun is called a dwarf star.
Okay.
Okay. Yes.
Do we know if it has planets?
And
if so, what's going to happen to it?
Well, if it had planets, it's already eaten them, except for the ones that are further out. And the ones that are further out, one of the things that would make Betelgeuse a very nice star to observe, if it had anything going around it. If it had anything going around it, we would know its mass, because the laws of motion tell you the mass. As soon as you see something spinning around it, you know, oh, that's so far away and it's moving this far fast, and so I know how big it is. I know how massive it is. We don't know the mass of Betelgeuse because it doesn't have anything, no planets at all. And for that matter, our own sun will dispose of 2 to 3 of its planets in the next 5 billion years. Our sun will eat Mercury, will eat Venus, and may eat the Earth when it becomes a red giant. Not a hypergiant, but it will become a red giant. Our sun will become a red giant, and then, because it doesn't have, and it will exhaust its nuclear fuel, and it will start then to do things that are nasty in the process of throwing off its own gases. The sun will do something like this. One of the best things that the sun could, the very best picture of what the sun could do, and this is so beyond perfect that it's not, our sun will never do something as nice as this, because this is the best picture ever taken of a star going whoop, whoop, whoop. Look at that.
That's the pulsar?
No, that's a star that has not exploded, but simply throwing off a large amount of its external gases. The star is still inside. The star is still doing a star-like thing, but it's thrown off its outer envelopes more than once. This is called the Edicarini, the Homunculus Nebula.
Is this an artist rendering or an actual photograph?
It's an actual photograph.
Wow.
It is one of the coolest things that is in the sky.
Did Hubble take this picture?
Yeah.
Wow.
Do you mean homunculus?
Yes, I do. I do. Thank you. I can never say that word. This is one of the prettiest objects in the sky. It is not a galaxy. It's nearby. It is a single star. It's called a planetary nebula, and our sun will do something like this. But unlike that, which is really pretty, it will do something probably more mundane and more like what I'm about to show you next. Although, yeah, so it could do something like this. This is mundane. Nevertheless, this star threw off that ring of stuff, and that it's not a ring, if you will, because you're only seeing it from it's a sphere. It's a sphere that you're looking through the center of, but the edges of you seeing it as a ring. If you any way you go around it, it's still a sphere. Yeah. So our sun will do that in 5 billion years, but it won't blow up. It will leave behind a dwarf star. A dwarf star is a white dwarf. The white dwarf will be the size of our planet Earth. The sun will become the size of our planet Earth after it sheds all its outer layers. Betelgeuse is already shedding its outer layers, and it can't do it fast enough. It's going to lose the battle. If it was able to get rid of all its outer layers, it wouldn't have to explode, but it can't do it. It's not going to do it fast enough. And if it doesn't do it fast enough, it's going to explode, and it's definitely going to explode in the next 100,000 years, more or less. If we knew more about it, we'd be able to pin it down better. But we don't know the actual mass of Betelgeuse because it doesn't have anything floating around it, so we could use it to measure the actual mass of it.
So what's the difference between that and our sun in terms of what's going to happen to it? Why is there a difference?
The difference is because our sun is not greedy in its consumption of nuclear fuel. So although it has 1/10 the mass of Betelgeuse, it's using it up at a rate of let's call it 1, whatever that rate is. Betelgeuse is using it up 1,000 times faster. And why is that? Because in the center of Betelgeuse, it's hotter. It's easier to fuse atoms together when it's hotter. You know, you aim two protons at each other, you know, and they are intending them to fuse, and they might miss each other because they repel. You throw them at each other fast enough, they're going to stick. So you can stick more protons together to make them into helium if the temperature is higher. And the temperature inside of Betelgeuse is much higher than the temperature inside the sun. So every time that there's an attempt at nuclear fusion, it misses inside the sun. Some reactions take 1 million years for this proton to meet this proton. It's been trying for 1 million years. Every time it misses. And once every 1 million years, these two protons make a helium atom. There's plenty of protons inside the sun. So the fact that most of them keep missing each other is not a problem because there's a ridiculous amount of protons. So it's enough to make all the heat that comes out of the sun. Inside of Betelgeuse, they're doing a much better job of fusing, and so they're burning up the fuel so much faster. So 10 times bigger, 1,000 times faster. That's what I started at the beginning of the lecture. I mentioned 10 to the third. Our sun will last 10 to the 10th years. It will last 10 to the 7th years. A factor of 10 to the third shorter years. Right.
So Betelgeuse was very unlucky in how it was constituted.
Right. But Betelgeuse was very unlucky in how it was constituted. But not only that, but Betelgeuse, in the process of becoming Betelgeuse, Betelgeuse was lucky. See, it's going to blow up. But then again, if you think of it, it's going to have children. The children will be us. Okay.
Well, it's hard to picture.
But we are the children of nuclear. Most of the stuff that's in our body was inside of a star. Okay, that's real. Okay, the hydrogen, which wasn't necessarily, is only 10% of our body. Everything else in our body was inside of a star. Come on, that's serious. That's serious. It blew up with a star. Okay, but pity the poor stars that were nearby. Okay.
What is it?
Yes.
So it's eating the nuclear. What when you say it's eating something else? I mean,
It's eating hydrogen and turning it into helium. Yes.
Eating
Eating
hydrogen,
helium, turning into carbon. Eating
Fine.
carbon, turning into nitrogen
So those are
and
the
oxygen.
nuclear, those are the nuclear reactions
Right.
going.
Right. And eventually it gets down to trying to eat iron, and it can't because iron.
Okay, so that's your ironing.
Then the iron
It's
simply
iron.
says, "I'm not giving up any energy.
Okay.
You can throw as much as me.
No
I'll
way,
just
okay.
suck it in, and I'll become a coolant rather than heat."
So meteors are made of iron. So ultimately, iron meteors went through that process
Right.
to become a chunk of iron.
Yes.
Yike.
Right. Those meteors were born. Everything was born in the center of a star.
So you're
The
saying the
planet.
meteors are iron.
There are iron meteors.
Okay.
Well, what happened with iron meteors basically is there were protoplanets that were being formed. Those protoplanets crashed into one another, and destroyed and the centers became available to be strewn around in the asteroid belt. But before the asteroid the protoplanet hit another protoplanet, the iron, which was everywhere in this protoplanet, was so hot it was molten because it was radioactive. It was radioactive. That's not because it was hot. It got hot because it was compacted. The gases that formed the protoplanet had lots of iron in it, and that fell to the center of the planet because it was heavy. And then the protoplanet hit another protoplanet, and then the planet fell apart, and you got the iron meteorites. They were in the center of these protoplanets. So the thing is that stars like Betelgeuse are not born in a solitary environment. They are born in a cosmic nursery. A giant molecular cloud, light years across, decides at some point, due to fluctuations in the fabric of space, or its time has come, or whatever the reason, decides start to condense into stars. And you get a lot of little ones, you get a few big ones. Betelgeuse was one of the big ones. So
Let him get a chance.
this is a picture of a small cosmic nursery.
Oh, that's interesting.
Okay, very small cosmic nursery. This is particularly obvious. They call this one the finger of God. The finger of God.
Oh, like the Michelangelo almost. Yeah.
Okay, but there's something more in this picture than just a rude gesture. Fact is that you can see something going on here. You see, this little guy seems to have a tail, and this tail seems to be in the same direction, and this, in fact, whole thing seems to be a tail. All of this seems to be streaming away from something up there. Something up there is doing something to this. This is a star being formed. This is a star being formed. This is a star being formed. And in here, there will other stars being formed inside of here. What's up there? There's a star like Betelgeuse that is busy disrupting the formation of these stars. These stars would like to be a Betelgeuse if they had a chance. They certainly have enough gas to begin with, but they don't have the time to do it, because when Betelgeuse turns on its nuclear furnace and starts burning brightly nearby, it blows away the gas that all those other stars would be forming from, and they don't get a chance to be Betelgeuse. So as soon as the big guy comes on the scene, all you get are the little guys. That's why there are mostly little stars in the universe, not the big ones. The big ones are born and they remove the gas, forming gas from all the little ones, and so they all go away. The little ones don't explode. Betelgeuse, for all its heft and orneriness, does explode. It gets to see the universe. The little ones, their revenge is they get to live forever. The little ones, the littlest ones can live for trillions of years. We're only going to live for a couple of 10 billion. The little ones live for trillions of years. Betelgeuse and the others, they die within 10 million years. Any day now, it could be.
We may be lucky enough to see it.
Yes.
I'm just a little confused about, okay, so the Big Bang started it all.
Yes.
And so that there's this death and rebirth going on constantly in the universe as we speak.
But yes, right.
Okay.
Okay, that's true. I no, I don't, but I'm not sure where you're going with. See, you threw the Big Bang in there. So,
Right. Well, we
could
don't-
leave the Big Bang out of the same sentence that you just said, and you could say there's birth and rebirth going on throughout the universe all
Fine.
the time.
Okay,
Right.
fine.
And there was a beginning.
There was a beginning, which
Right.
is theorized to be the Big Bang.
That's right. That's right.
Are you saying that Betelgeuse is above that particular?
A Betelgeuse-like star.
A like one, okay.
Yes, because this is now. Well, not now, because in fact, anytime you look out from distance, it's not now; it's then. The sun is 8-9 minutes away of then. The Betelgeuse is 700 light years. That means Betelgeuse could have exploded 700 years ago, and we wouldn't know about it until tomorrow, when the news reaches us, because the news is rather slow in the universe. It travels at the speed of light, and although the speed of light seems awfully fast, the universe, and I think this is a joke on the universe, I think the fact that that the speed of light is so incredibly fast, and yet it's minuscule compared to the size of the universe. A light year, that's light traveling for a year, trying to say something to light year away. And and the nearest star is 4 light years away. That's the nearest. How could that be? There's all this empty space between us and the very nearest star. The universe is not made from light years. They're made from thousands of light years and millions of light years and billions of light years. So basically, everybody is isolated. That's just another topic entirely. I just want to see if there's anything else I wanted to talk about Betelgeuse. There's actually lots to talk about, but
How do you spell Betelgeuse? So it sticks in my
Please.
mind.
You get a prize for
B-E-T-E-L.
B-E-L-G-E-U-S-E.
yeah, it's going to show up on the screen any second.
B-E-T-E-L-G-U-E-S, okay.
Betelgeuse, and there it is in the sky. Have you seen the Orion Nebula? There it is. So that's the Orion Nebula. Okay, that is Betelgeuse up here, and right there, and that is Rigel, which is normally very bright, but now Betelgeuse is dimmer than it. There's the belt of Orion. There's the sword of Orion, and there's the shield of Orion. Yes. And the head. Yes.
How much is the dimming that was observed?
One person said 60% dimming. 60%.
60.
60.
That's for Christmas.
60. Yeah. 60.
That's not big.
60%. Another person said 2.5 times. That may be the same thing. This is a picture of the dimming of the star. Look, this is actual. Betelgeuse is a variable star. So over a period of from 2014 till now, this is what Betelgeuse has been doing normally. And it's just now that it's doing this. It's just now that it's doing this. You notice this is a funny thing? It looks like it's getting brighter, right? And the reason it looks like it's getting brighter is because astronomers have to live with something that shepherds came up with years ago. You look at the star and you say, no, that's the first brightest star in the sky. Okay? So, that one, that's not as bright, that's the second. Okay? And that one, that's the third brightest. And fifth and sixth. You can see to the sixth magnitude. Okay? 6 is dimmer than 1. So the greater the magnitude of a star, the dimmer it is. And eventually, when you started really doing things, you say, well, gee, the sun is one of those stars. What is its magnitude? Its magnitude is minus something. Magnitude of the sun is minus. All the way down there, the dim things go all the way up there. So as Betelgeuse gets dimmer, it goes up. The magnitude goes up.
What does magnitude mean?
Well, magnitude normally for us means size. And we think of size, bigger the size, the higher the magnitude. So that would make sense for this. But no, in astronomical terms, when something has a bigger magnitude, it means that it's dimmer. Just because of the shepherds.
It's amazing.
What did they know? and there are other artifacts
Those shepherds.
other artifacts in astronomy. Remember I showed you those rings around the stars, and I said that I use that I use the word planetary nebula. That ring around the star, that's called a planetary nebula. That's completely a wrong word. Planetary would imply that it's somehow like a planet, but in fact it's nothing like a planet. It's just a ring. They called it planetary nebula because they had no idea what it was, and some guy was the first guy to say, "Oh, that looks like a planet." So it became a planetary nebula, even though it has nothing to do with planets. The stars in the sky are arranged by "Oh, be a fine girl, kiss me," and that's because originally it was A, B, C, D, E, F, G. It turns out that didn't make any sense. The person who figured out how to rearrange the stars so they did make sense ended up rearranging them in a way that only can be understood if you have an acronym. Thank you. I never would have gotten the word. Anyway, and then I promised. So that's sort of the end of that. But I did promise on one of the ways I'm trying to create. I have my YouTube channel is thanks to you guys is doing quite well. I mean, comparatively, and I'm now gathering new viewers at 2 and 3 a day.
Wow.
That's yes. So 211 subscribers. 3 days ago, it was 200 subscribers. Okay. So this class is picking up speed. And look, you can see this is the number of subscribers over there. You know, on a daily basis, I'm getting more subscribers every day. Well, one of the ways I get subscribers is by shilling on the web. You know, so I figured this out. I mean, there are a lot of ways of getting subscribers. In order for me to actually have this be reasonably large number of people, it wouldn't have to be 211 subscribers. It'd have to be 211,000 subscribers. Then we'd be talking. Okay, but at 211
You gotta
subscribers.
start somewhere.
Yeah, we have to start somewhere. So 211 subscribers. Believe me, I am super pleased. So one of the ways I shill on the web is I go to somebody else's website and I look at their video, and then I make a comment. You know, I don't normally make comments. I'm not that kind of person who will comment on other people's video, but I comment on this astronomer's video, and I say, "Nice job. I really enjoyed it." I mean, I only just do it if I feel that way, but nevertheless, I write it. And the title of so let's subscriptions. So one of the guys I've subscribed to is space-centric. Okay. Now,
One of the great challenges in this world is knowing enough about a subject to think you're right.
I like him. Okay. So
You guys are awesome. I hope your new decade is going well for you. Someone was like, a new decade doesn't actually start.
So this guy is his name is I forget his name, but his
Navy doesn't have
site is
MOSs,
space-centric, and he's on the web all the time, and he has
I'm not sure who we're talking about.
87,000 subscribers.
Oh, dear.
Okay.
And
And this particular video, which he's put on the web yesterday, has 34,000 views. And what I do is,
I got a torn hip now. And it's still
so what I do is I put my comment
Anyway, I don't even know if you're talking
on there
about
so that you can see it.
So I thought I'd join
Good
in.
job. I'll play this landing in my class tomorrow. Watch my
Yes,
class
don't
on
get a break till
YouTube.
you graduate.
Ah, there you go.
Right? So now
Stumpy.
I promised that I would play his landing on YouTube. So that's what I got to do right now. And then it'll end up on my channel.
If something goes wrong, NASA wants to have a window for crew dragging the dock with space
Is
station.
he any good?
He's terrific. He's a real. He quit his job, his daytime job. He does this full time now.
Makes money.
He makes money. This is his full time
From
job.
home.
T-shirts. How do you make money?
T-shirts.
How do you make money on the web?
How much is YouTube?
On YouTube.
Selling some t-shirt below.
Well, he does sell these T-shirts below, for God's sakes. But that's the only way he makes extra money. No, see, the thing is, when I watch this, I see ads on the screen, and those ads I'm watching those ads because I'm watching his show. So Google charges people for those ads. So they give those people who attract viewing eyes, they give some money back to them. So you can earn money if you have enough money.
So he doesn't have to get the advertisers.
Google gets the advertisers. All he has to do is his thing.
Be popular.
Be popular. He's sweet. I like him a lot. There's a lot of other guys on the web. There's 5 or 10 guys on the web that are always like telling you the latest space news. You know, some of them tell you astronomy news, but that doesn't come up as frequently. But with SpaceX, there's SpaceX news all the time. And yesterday there was a SpaceX landing, a SpaceX launch, which was in fact annoying as far as astronomers are concerned, because
Putting too much in the sky.
they're putting too much stuff in the sky, and they're really starting to do some nasty stuff. Yeah.
Another car.
Is
Yes,
that
the
the car
latest
guy,
thing.
or is
So-
that Amazon guy?
So this is the landing of that booster rocket that launched that rocket, and I think shortly you'll see. Is it the landing? It's coming down. Anyway, so he's taking pictures of his spaceship as it's flying, and we get live coverage of that. And this is the spaceship as it's landing, and taken from the spaceship as it's landing.
They're recovering them all now.
And there's the landing pad on a barge. The barge, I think, is called "Of Course I Still Love You," because some of them fell off.
Oh.
So the barge is saying, "If you fall off, I'll still love you," but the rocket is coming down now, and will land successfully. And this booster here.
9 first stage landing today. It was awesome. Falcon 9. This is the 4th landing of the vehicle and the 48th Falcon 9 first stage landing today.
So this is the 4th landing of that particular rocket. That rocket has landed 4 times.
Yeah.
Okay, is that cool? And this is, I think he said, the 48th successful landing of a SpaceX rocket. That's very cool too. But the problem is that what he did is he launched something like 60 satellites at the same time. And those 60 satellites, each of them reflect the sun when they pass overhead. And if you are an astronomer looking through a telescope, trying to photograph something, and then you see 60 satellites running across your field of view, and he's planning to put up 30,000 satellites.
Why?
For what point,
So
what purpose?
Elon Musk.
Question,
Let's
why?
speak to space junk.
Well, the space junk, of course, comes up as one of the things, but the reason he's doing it is so the shepherd, in that same shepherd, can get cell phone service. Because you see, the cell phone tower is too far away. They're not going to build a cell phone tower every 50 feet, every half a mile. So Elon Musk is building cell phone towers in the sky. That's a simplification, by the way, but nevertheless, true.
I was in Cadman Plaza this weekend, and it was an open field, buildings all around, and we could not get cell service. In the middle of Brooklyn, with buildings all around, no cell service.
Well,
It seemed astonishing.
But you have to know that Elon Musk doesn't care about your problem. He is not going to try to solve that problem. He is not. So I did say it was a simplification. The truth is, he is not going to try to transmit from here to your cell phone. He's going to transmit from here to a device that's about this big, sitting in your backyard, which can then transmit to your cell phone. You need a bigger antenna than your cell phone to pick up his signal, but you don't need something bigger than this blackboard. You just mount a little thing and it gets the cell phone service, and you can sell the cell phone service to your neighbors at a reduced price. So everywhere in the world, they'll get cell phone service, because everybody in the world, somebody's going to set up a little tower and sell cell phone to their shepherd neighbors, for a shekel or two, or whatever. But the world was going to be, and not only is it going to be sent down, but you will be able to actually send a signal. I will type something here, and my daughter in Istanbul will receive the email, but it will have been traveled over his satellites, because he can compete economically with the wires that are running under the ocean with his satellites that are flying overhead. each of the satellites will transmit data to the next satellite, which will transmit to the next satellite. Oh, you're there? Okay, I'll transmit to there, and then okay, there. And it will crisscross the world, making 5 or 6 hops before it ends up in my daughter's computer.
But won't it interfere massively with traffic?
What kind of traffic?
Space traffic, rockets, missiles, radio transmissions, all sorts of governmental
Yeah, take them one at a time. Will it interfere with other satellites? And the answer is, well, Elon Musk has thought of that, and he says no. You can take him at his word, or we can argue. Okay? He will know where every one of those things are in the sky. We will be told where every one of those things are. He will make sure that those satellites are capable of not hitting other satellites. He'll try to be very careful. He has to be very careful because, in my opinion, he can't get it right. But in your opinion, he can't get it right. But he will try to get it right, yes.
But 3,000 is nothing over the surface of the Earth.
Yes, 30,000. 30,000 is nothing. It really is nothing. It's really nothing.
It's nothing on the surface.
Space is big.
There's an ocean, even
There's not a lot of them. I mean, it's really not a lot. You can, but nevertheless, satellites have hit other satellites in Earth orbit by accident. Even though their space is big, there's been one accident, totally unintended, where 2 satellites hit each other, right?
I thought that wasn't an accident, it was a Chinese test.
No, there was a Chinese test in which they did that, but there was a completely accidental one that occurred in which nobody saw coming, and that, so you could say they can try to fix it, make sure it doesn't happen, but that doesn't mean it won't happen.
What
in my
was the
opinion.
consequence of that collision?
Well,
Nothing, I suppose.
No. The consequence of the collision is people see instead of having 2 things in the sky, now you had 20,000 things in the sky, and some of them are as small as paint chips.
Right.
And paint chips, which if they're flying in the same direction as you can just reach out and go, oh, that's a nice paint chip. But if it happens to be flying in the opposite direction, that's 18,000 miles an hour times 2. It's coming at you at, you're going 18, it's going 18, 36,000 miles per hour headed at you, a paint chip. They cannot, literally on Earth, they cannot launch a bullet at 36,000 miles per hour. They can simulate that, but they can't do it. It's going to make a hole in the spacecraft. And the only question is, how well is the spacecraft designed to guard against paint chips? And the answer is, they do design them to be guarded against paint chips. But screws, I'm not sure about screws and the rest of it. So
it may destroy the satellite.
So you saw this movie. It was called, anybody know the name of it? In which there was a collision of 2 spaceships in space. Okay, and what happens is it reached a critical mass in this movie. So 2 spaceships collided. The spaceships fragmented into many pieces, and the fragments then hit all other satellites in the orbit, causing them to fragment. And then you get this entire sphere around the Earth, which is covered with increasingly small particles that can increasingly hit each other and make this space impenetrable. That is a real possibility. They're not dismissing that whatsoever. There's actually a guy who's figured out exactly how hard it is to do that, and the answer is not very hard. If we have a space war, and the Chinese decide to blow up satellites, they will not only blow up our satellites, they'll blow up theirs as well, because the space will be filled with debris, and we won't be able to pass through it on our way to Mars. Who knows? The other thing that you have a conflict with Elon Musk is it's not Elon Musk who is, he wants to do this, and he's got the rockets, and by the way, Elon Musk has figured that he's not going to make money by launching satellites. That's not a money-making thing. You would think it's, he's the guy who launches satellites. He's the money-making guy. No, he figured out that he can use his own satellite launching capability to launch his own satellites. And those satellites, he'll be able to sell the value of those satellites, the internet capability of those satellites, to customers, and he'll be able to make makes money 10 times faster than he can make money launching other people's satellites. And that money he's going to use to do what? Guess what he's going to do with it? He's going to take us to Mars. But in the process, he's going to destroy this space and the skies for astronomers. But he's not the only guy who's doing this, because guess what? He may have been the first guy to actually succeed in starting this process, but he's not the first guy who's doing it. There's another European consortium that's launching 1,000 of them, and then guess who won't be left out? A little guy named Bezos. Right. He's got a plan approved by Congress to launch a pile of them as well. So Elon Musk is going up for 30,000, Bezos going up for 3,000. Everybody and their mother is going to be launching satellites doing the same thing. And some of these people, see, Elon Musk said, listen, I really care about you astronomers. I'm really going to paint them, I'm going to paint my satellites black in your honor so they do not fly and destroy your pictures. But painting them black is not an easy solution. If you paint a satellite black, well, you're shaking your head as if you know what I'm about to say.
I think I do.
What do you think I'm about to say?
Well, it's like me driving my bicycle at night, wearing a dark coat and my an invisible bike. I become invisible.
Well, that's good, but what's the problem with a black satellite? What do you think the problem with a black satellite is?
Doesn't reflect anything.
That's a good thing. That's what you want. It has radio antennas. We're talking about radio waves. It doesn't reflect. That's good. Black satellites, what's wrong with them is they get hot because they're black and they absorb the heat, so their electronics will fry. So if you make them too black, then the satellite doesn't work. So Elon Musk is sending up some satellites that are various shades of black to see which ones will.
Shades of gray.
Shades of black.
50 shades.
Right. And where was I going with the next thing? Shades of black. So other people will not, they don't care. Other people won't care. So they'll be sending up shiny satellites because I don't care. So anybody on Earth can send up a satellite because there's no rules. There are rules when it comes to launching, doing things with respect to radio. You're not allowed to pollute the radio channels with your hobby transmitter. There are rules. If you transmit in somebody else's bandwidth, the bandwidth police will come after you and stop you anywhere in the world. But if you go up and pollute the sky above everybody's head, there's no rules that tell you you can't do that because there's no international law that says you can't do that. So we could really mess with the skies.
And now you have Space Force. And the Space Force will send up average like cars. It'll be so frequent.
No, Space Force is one of the few things that Donald Trump said, publicly in his normal rantings that makes sense. We already.
I'm not complaining about it.
No, I'm not complaining about it either. The fact is that having a separate branch of the military that is in fact associated with launching military satellites, they already do that. They launch them all the time. That just now we'll call them the Space Force. They've been doing it for a while. So it's just a rebranding, in fact, because he's not going to, if he's thinking about sending up nuclear weapons, that's against international law.
No, he's
No,
not.
no. So it's just Space Force.
It's not a problem,
No, right. So what's not a problem?
but it's against international.
Oh no, of course it's not. The fact, it's not a problem. I mean, you can do anything.
Is there any attempt to form some sort of international body that can regulate something?
There is talk.
Oh, okay.
Well, it's the UN, it's talk.
Yes, it's talk. But to try to get nations these days, which are increasingly nationalistic, to agree on things. I mean, look, the United States doesn't believe in climate change, right?
Right.
Right?
No, wait a minute.
Only one
That's not
person.
mistaken. One man doesn't believe in time.
Right. Okay. So see you next week. Make sure you sign the attendance sheet before you leave, and classes are every week. Welcome.
Good class, thank you.
Thank you. Is there some website or something you can sort of direct me towards? Just basic vocabulary so that I understand a nebula versus sort of give me that basic.
Well, the thing is that, there is probably, first of all, we have this thing called Google.
Yes,
Right.
yes.
So if you literally said, if if you Googled a dictionary of astronomical terms, I'm sure within 12 seconds you'd have them.
Right, okay.
So that won't solve your problem, because you have to read it. And unless you really want to read through the 200 terms.
Yeah, it needs to have some sort of context or,
Astronomy 101. Right? Hold on, let me just turn this off.
oh.
Oh, be sure to get his